Hello everyone, welcome back to Smart Techie. In this video, today we are going to learn how to refactor a legacy code which we are not able to maintain. We are not able to add any new functionality. We are not able to test the code. So it reached to that level. I wanted to showcase how we can refactor that legacy code by applying rules design pattern, and I will show you how I am applying solid principles during this refactoring process. Without taking time, let's dive in. To demonstrate how this refactoring is going to happen by using a legacy code and then the refactored code, I have created two Spring Boot projects. One is the legacy user service, the other one is refactored user service. Obviously, when we create any application which goes for 3 years, 5 years, so people are going to maintain that code base. When people are maintaining that code base, the developers will come and join and they leave. So when people are coming and adding new functionalities, people try to add so much of code in a single method by having multiple if else blocks. And during the defect fixes, people try to add if condition to add certain kind of scenario. So that's how the legacy code will evolve and we cannot manage that code. It becomes as a maintainability issue. It becomes a toil for the team where we need to refactor it. Now let us see how a legacy code looks like. So this is a sample code, but recently I came across so many legacy codes where we are already having or seeing so many ladder ifs, but I just created a sample conditions here to showcase how the legacy code looks like. So in this example, I am trying to build an API to register a user by taking user's username, password, email address, and the age. And I wanted to validate those conditions before registering and putting that user info in the database. So if you look at, I have a controller where there is an endpoint exposed slash register, and then I do have a service which has just validate user followed by all other methods. If you look at the controller, before inserting the record into the user table, we are validating the user. If you look at this validate user method, we are taking the user supplied information and we are trying to check the username length, password length, email syntax, and the age. So essentially, this is a legacy code where we might have started with some conditions and later on, other developers might have implemented other validations and some other might have fixed the defects. So the code looks like this. It is so messy now. When a new person try to understand this code, it is very tough. They cannot understand and they cannot debug it. And writing the unit test for this kind of code is very tough. Then how can we refactor this particular legacy code by applying rules design pattern as well as S.O.L.I.D principles? Now, I wanted to refactor that legacy code by using a rules design pattern. Before diving into the code, I wanted to showcase how my class diagram looks like. If you look at this class diagram, I have created an interface to validate the rules, and then there are a couple of the rules implementations. This interface is having just a validate method which is taking user as the input and which returns whether this validation is successful or not, a boolean value, and the error message. For each validation, if it fails, I am going to add an error message. So here I have implemented username rule and password rule to check the password, and then email, and then age. And there is an evaluator which contains the list of rules which I wanted to validate. So now I am getting a list. In this list, I am going to add what rules I wanted to validate and then the evaluate. So this evaluation goes through one by one each validation rule which is part of a rules list, and it will say whether this validation or rule check is passed or not, and it again takes the user as an object. So in this class diagram, if you look at, I have applied two solid principles. One is every class having a single responsibility. For example, username rule, the responsibility of this class is only one, that is to check the username validation, and password rule to check only the password validation. So the single responsibility we have achieved with this design pattern. And the second one is open closed principle. So if you look at these implementations and this interface, this code is open for extensibility and closed for modifications. So we can create as many rule implementations as we want by implementing this rule interface, and then we can apply that for the evaluator. So it is open for extensibility, closed for modification. So we have achieved two solid principles by applying a rules design pattern when we are refactoring the legacy code. Now let us see the refactored code by using a rules design pattern, how we applied a rules design pattern, what we discussed when we are going through the class diagram. So here, this is the same user service, same register API call I just refactored by applying the solid principles, the rules design pattern. So here again, we do have an user controller which is having /register API endpoint, which takes user, and then it goes for validation. So there is a user service which has a validate user. If you look at, I have created validate rule which has two methods. One is validate, which returns a boolean value after the user object is validated, and then an error message. And this interface is implemented by username rule, password rule, email rule, and age rule. And every implementation is having only single responsibility, and this validate rule is open for extensibility and closed for modification. And then there is an evaluator class which takes the list of rules and which goes through each rule and validate. If any validation fails, we can just add the error message which is generated from that validation. And if you look at the flexibility of this refactoring code, we can add unit tests very easily because every class is having single responsibility. Whereas in the legacy code, the same user service is having multiple responsibilities, checking multiple rules. So applying a unit test case for that is very hard. In this user service, and the beauty of this refactored code is that I hope now you have seen how we can refactor a legacy code and how we can apply solid principles during the refactoring and how we can apply rules service. Now let us run these two code bases. I am running legacy user service as well as refactored user service. These are the two Spring Boot applications running on two different ports. I just wanted to demonstrate the APIs, the register API. I have created two endpoints. One is for the legacy registration service and the other one is for refactored registration service. If you look at the API wise, both of them are similar. There is no issue with the request and response. So if I trigger this legacy register API endpoint, which is running on port 8080, you'll receive the validations. The similar way, if I apply, if I send an API request to the refactored service which is running on port 8081, it validates and gives the response back. Here the user validation is failed and it is giving that username must be at least 5 characters long. That is the validation and that is the error message we got it. So you won't see any change in terms of request and response because we haven't changed anything there. The only change we have done in the service layer, where in the legacy code we could not able to maintain that code, so we refactored that so that we can easily maintain it. I hope you enjoyed this session how we refactored the legacy code. Thanks for watching. If it is helpful, like, subscribe and share and provide your thoughts in the comments until we see in the next video.